Hey guys, so this is 1.6 part 2 over rational expressions. In the last video, we learned how to simplify rational expressions and to multiply them. Now we're going to move into dividing rational expressions. So dividing rational expressions is actually very similar to multiplying rational expressions. And if you remember how to divide fractions, it'll make sense why. So dividing is like multiplying, or is multiplying by the reciprocal. Therefore, to divide rational expressions, flip the second expression and follow the steps for multiplication. So just like if I were dividing two fractions, like 2/3 divided by, 1/8. The way you would do that is you would flip the second fraction and multiply straight across. So same thing with these rational expressions. You're going to flip the second one and then just multiply. So it's going to be very similar to what we did yesterday, but just going to have to remember to flip that. So step 1, flip the second fraction and change the operation to multiplication. Step 2, follow the steps for multiplication. All right, so let's try it out. Divide each expression. State any restrictions on the domain. So we are not worrying about that right now. You can ignore that direction. Okay, so change it to multiplication and flip that second fraction. Times, flipping it. Okay. So now it's exactly what we did yesterday, which if you remember, step 1 was to factor all numerators and denominators. So let's factor these. A plus 2, A minus 2 in the first numerator. We've got difference of squares there. We have difference of squares in the denominator as well. A plus 1, A minus 1. Can't factor that one. In the denominator here, we have a GCF of A. Okay, now if you'll remember, the next step after you factor everything is to divide out anything that appears in the numerator and denominator. So if I've got A plus 2 here and A plus 2 down here, those cancel. And then I've got A plus 1, A plus 1. So those will divide out. Okay, that leaves me with an A minus 2 in the numerator and an A minus 1 times A in the denominator. I'm going to put the A first, which can be simplified as A minus 2 over A squared minus A. Just distributing that A in the denominator. All right, one more, number 9, and if you want to pause the video and give this one a try on your own, feel free. Just don't forget to change this sign and flip the second fraction. Okay, so flip the second fraction, change it to multiplication. Now we get to factor everything. So factoring this first numerator, I'm going to do it off to the side because it does have that leading coefficient of 5, and so I'm going to need to use grouping. So I'm looking for two numbers that multiply to AC, which is 15, and add to negative 16. That'll be 1 and 15. Negative 1 and negative 15 to give me that negative 16 in the middle. Okay, now factoring by grouping here. Okay, so I've got that first numerator factored, and so 5z minus 1, z minus 3. And in the second one, leading coefficient is just 1, so I really don't have to do all that work. Two numbers that add to 1 and multiply to negative 12. That's going to be 4 and negative 3, so I can just do z plus 4 and z minus 3. Okay, in this next one, it's a binomial, and I've got a GCF of 2z squared. So that leaves me with z plus 4. And finally, in this denominator, we've got a GCF of 6z. Okay, now let's cancel anything that appears in the numerator and denominator. 5z minus 1 there, z plus 4, z minus 3. Now I can reduce this 2 over 6z to 1 over 3. And then one of these z's can cancel, leaving us with just one z in the top. That is all that's left. Just z. Whew. So all of this, when you actually divide those two rational expressions, all that's left is z. Awesome. So let's move on to our next page, which is all about adding and subtracting rational expressions. So first, let me remind you of how we add and subtract rational fractions. Okay, so if I had 1/3 plus 2/5, I would need to get a common denominator before adding, because your denominators have to match, and then you just add the numerator straight across. So in order for these denominators to match, I would multiply this first fraction by 5 on the top and the bottom. I would multiply the second fraction by 3 on the top and the bottom, so that now I have 5 over 15 plus 6 over 15. Okay, so now the denominators match. Essentially, all I did was multiply this first fraction by the denominator of the second one, and the second fraction by the denominator of the first one. Okay, so often that is what you need to do. Okay, now that they match, I'm going to add straight across the top. 5 plus 6 is 11, and then the denominator stays 15. So that's how you add fractions. Same thing with rational expressions. You still need to get a common denominator, and then you still add across the top and leave the denominator the same. Cool? So, step 1. Factor all numerators and denominators completely. Factor the numerators and denominators completely. And then find your least common denominator, LCD. That's your least common denominator. And then multiply each fraction by what its denominator is missing from the LCD. Step 4, add numerators. That's typo. add numerators, and leave the denominator. So just add the numerators and leave the denominator. All right, let's see how that looks. So for number 10, we've got 3 over 10z to the 4th plus 2 over 15z squared. So in this first denominator, you could factor that if you want. That's 2 times 5, z to the 4th. This one is 3 times 5, z squared. So if you look at the numbers and think, what is this one missing that this second one has? Well, it has the 5, but it doesn't have this 3. So you have to multiply by a 3 here so that they'll match. And then likewise, this first one has a 2. The second one doesn't have that in the denominator, so I would need to multiply by a 2 here for them to match. Or, if you wanted to, without doing that factoring right there, just because this one's a monomial in the denominator, you don't actually need to do any factoring. You could just think, what would the LCD be? What's the smallest number I could get by multiplying each of those? And that would be 30. How do I get 30 here? I multiply by 3. Have to do to the top whatever you do to the bottom. How do I get 30 on the second one? I multiply by 2. Okay, not only is the LCD 30, but you also have to look at that z, so it's always going to be whatever the higher exponent is, right? Because I can't make this one go down any, but I can make this one go up. So to make them match, we're going to go for z to the 4th. Okay, so for the second fraction, in order for that to become z to the 4th, I'm going to multiply by z squared on the top and the bottom. Okay, so let's write all of that out. We've got 9 in the numerator, 30z to the 4th plus, and in the second rational expression, I get 4z squared over 30z to the 4th. Perfect. Now our denominators match, so we will move on to adding the numerators and leave the denominator the same. So I'll have 9 plus 4z squared over 30z to the 4th. Okay, next one. Let's see what our LCD would be here. Okay, so in this, looking at just our coefficients, I've got a 2 and a 10 that I need to match. The easiest way to do that would be multiplying this 2 by 5 to get 10. Okay, so for our LCD, I can get 10 by multiplying by 5 here. Okay, now for our variables, I have an x and an x cubed, so we're going to have to get that x cubed, always using that higher exponent. And for the y, I see a y squared, so I'm going to have to go for that y squared for both. Okay, so I need to multiply by x squared in the first rational expression to get x cubed. And then I'm going to have to multiply by a y in the second one to get y squared. Okay, so let's write all of that up. 15x squared over 10x cubed y squared minus 7y over 10x cubed y squared. Great, now our denominators match and we can subtract across the numerator. So 15x squared minus 7y leave the denominator the same. And that's it. Number 12. So on number 12, you can see that our denominators are pretty close to matching. However, they need a little work. Okay, so the signs are different. So if I actually just switch these two terms on the second denominator, that would be negative m plus 5, right? The sign in front of the m would go with it, and the 5 is positive. So these are very close to matching. How about if I factor out the negative on the negative m plus 5? So that would become negative m minus 5. That's what that is. Okay, so to get them to match, I could just multiply the first fraction by negative 1 on the top and the bottom, so that they're both negative m minus 5. Or alternately, you could multiply the second fraction by negative 1 on the top and the bottom, so that both of them have m minus 5 as the denominator, and that's what I'm going to do. Okay, so if I multiply, let me go ahead and rewrite this. 7 over m minus 5 plus 2m over negative m minus 5. So all I did was switch those two terms and factor out the negative there. Now to get those to match, like I said, I could multiply by a negative 1. On the top and the bottom. So that's negative 2m on the top. And then those two would cancel, right? So it becomes just m minus 5 in the bottom. Okay, now that our denominators match, we will add straight across the top. 7 minus 2m over m minus 5. So it's all about getting those denominators to match, and then remembering that you add across the top and leave the bottom the same. All right, our last problem for today. We'll finish these notes in part 3. All right, so step 1, now on this one we actually do have some factoring to do. So we're going to factor both of these denominators. So two numbers that add to 2 and multiply to negative 15 are going to be positive 5 and negative 3. And then in the second fraction, it's going to be the difference of squares. Taking the square root, that gives me x minus 5, x plus 5. Okay, so now you have to multiply what's missing in this denominator. Actually, let's write our LCD out real quick. LCD. So for LCD here, it's going to be the combination of all factors in the denominator. So I need to have x minus 5, x plus 5, and x minus 3. So just writing each of these one time. Okay, so now whatever is missing in this first denominator, I need to multiply by. So it's missing the x minus 5, so I need to multiply by x minus 5. The second rational expression is missing the x minus 3 from the denominator, so I need to multiply by x minus 3 in the top and the bottom. Okay, so now that my denominators match, I can subtract straight across the top. So I'm just going to rewrite that as 4 times x minus 5 minus 6 times x minus 3. And then that's all over x minus 5, x plus 5, x minus 3. Okay, now to simplify this, I'm going to distribute and combine like terms in the numerator. So make sure that minus gets distributed to both terms there. Very important. Because if you had tried to distribute right here, we might have forgotten about the minus. So just don't forget that that minus is attached to the numerator. So 4x minus 20 minus 6x plus 18 all over x minus 5, x plus 5, x minus 3. And then finally, we can combine like terms. So negative 2x minus 2 all over x minus 5, x plus 5, x minus 3. All right, and that's it for these notes today. So good luck on your assignment, and we'll finish these notes tomorrow.